Welcome to a lesson on how to multiply a whole number and a fraction using a fraction wall. To use a fraction wall, we first define the long blue rod as one whole. So if we cut or denominate one whole into two equal partitions or two equal pieces, notice how we'd have two 1/2 rods. If we cut or denominate one whole into three equal partitions or three equal pieces, we'd have three 1/3 rods. If we continue this, notice how the fraction wall also contains 1/4 rods, 1/6 rods, 1/8 rods, 1/12 rods, and 1/24 rods. So looking at the first example, we have 3 times 1/24. We can think of this as 3 copies of 1/24. So if this small rod is 1/24, the product would be 3 1/24 rods. So just to emphasize this, if we count or enumerate the number of 1/24 rods, notice how we have 1, 2, 3 1/24 rods. And the length of these 3 rods would be 3/24, which is our product. 3 times 1/24 is 3/24. Next we have 4 times 1/6. So now we have 4 copies of 1/6. So to illustrate this, we would have 4 copies or 4 1/6 rods. So if we highlight 4 1/6 rods, this models our product. Again, if we enumerate or count the number of 1/6 rods, we have 1, 2, 3, 4 of them. So the length of this rod would be 4/6, which is our product. But notice how we could also express this length using different rods. Looking at the 1/3 rods, notice how 2 1/3 rods would have the same length as 4 1/6 rods, which means 2/3 is equivalent to 4/6, so we could also express this product as 2/3. Typically, we would want to express a product using the longest rods possible. 2/3 is called the simplified form of 4/6. Notice the fraction 4/6 has a common factor of 2 between the numerator and denominator. We could have also expressed this product using a fraction with a denominator of 12, because we can use 1/12 rods to form a train of the same length. And we could also have used the 1/24 rods to form a train of the same length. But again, typically, we do want to express a product using the largest rods possible. And now for our last example, we have 2 times 3/8, which we can think of as 2 copies of 3/8, or if we want 2 sets of 3/8. So one copy of 3/8 would consist of 3 1/8 rods. So this would be one copy of 3/8. But we have 2 copies of 3/8, so we need another copy of 3/8, which would look like this. So the length of this train of 1/8 rods represents our product. If we count or enumerate the number of 1/8 rods, we have 1, 2, 3, 4, 5, 6 1/8 rods. So the length is 6/8, which is our product. 2 times 3/8 equals 6/8. But again, if we take a look at our fraction wall, we can also express 6/8 using larger rods. We could use 3 1/4 rods. Notice how if we use 3 1/4 rods, the length of the train would be the same as the 1/8 rod train, which means we can also express the product as 3/4. And once again, we do consider 3/4 the simplified form of 6/8. Once again, notice how the fraction of 6/8 has a common factor of 2 between the numerator and denominator. I hope you found these examples helpful.